Hello students, I hope you all are doing good and preparing for your PUC board exams. So today's session I have planned as a practice session. Okay, so I have picked the questions from uh, previous year that were asked from this chapter, vector algebra. Particularly from this chapter, all the questions like the similar questions I have skipped, I have tried to exhaustively cover more questions from this chapter. Okay, yeah, so what you could do is you could pause the video and try to solve it on your own, and then you can look at the solution part. Okay, so let's start today's session. Okay, yeah, so the first question that we have is the unit vector in the direction of the vector uh, a equal to I plus j plus 2k. Okay, so let's see how to do these kind of questions. Okay, so for us the vector that is given to us is a is equal to I plus j plus 2k. Okay, fine. So they are asking us to find the unit vector, and we know the formula for unit vector a cap is equal to vector a divided by modulus of vector a. So I need to find the modulus of vector a. We know the formula for modulus, it is nothing but the square of the components, x square plus y square plus z square. So here what is my x? X is 1, and y is also 1, and my z is 2. So I'll just put it here, 1 square plus 1 square plus 2 square. So what do I get? I get 6, right? Yeah, so the unit vector is nothing but a vector, that is I plus j plus 2k divided by root 6. So the correct answer is option A. So it was a very simple question. The formula that we have used is vector divided by modulus of that vector. That will give us the unit vector. So this was asked in 2023. Okay, let's move on. Let's see what is the next question we have. So they have asked us define co-initial vectors. So the name itself says co means same, co-initial. Two vectors having the same initial point are called co-initial vector. So this is important, same initial point. Okay, that was a simple one. Moving on. Next, yeah, this is the most expected question. They may ask you this projection vector. So this is very simple. Let's look at this. Find the projection of vector A on vector B. So the vector A is given to us and projection of this vector on vector B. So the formula is projection of vector A on B. The formula is A dot B divided by mod A divided by the modulus of the other vector. Okay, the dot product and divided with the magnitude of vector B. This will give us the projection of vector A on B. So yeah, we'll be doing the dot product. So 2y plus 3j plus 2k dot I plus 2j plus k. Okay, and modulus of vector B, we take the square of each of the components. In vector B we have 1, 2 and 1. So 1 square plus 2 square plus 1 square. Dot product we just multiply, right? This is multiplied with this. 2 into 1 is 1 plus 3 into 2 is 6 and 2 into 1 is 2. Yeah, the square part will get 4, 5, 6. So the answer is 6, 7, 8, 9. 9 by root 6. Root 6 can be further written as root 3, root 2. 9 can be written as 3 into 3, root 3, root 2. 3 can be written as root 3, root 3, 3, root 3, root 2. So the answer is 3 by 2, root 3. This is what you get. Okay, moving on. So this is very important. Projection of vector A on B is dot product of A and B, and we will divide it with the modulus of the B vector. Moving on, you can expect a similar question. Yeah, so this is the most popular question. they can ask you find the area of the parallelogram whose adjacent sides are determined by A and B. So area of the parallelogram, the formula is the formula for area of parallelogram we have studied, that is the magnitude of the cross product of A and B. So first we'll find the cross product. So we all know how to find the cross product, right? We'll have to find the determinant I, j, k in the first row. In the second row, I'll write the components, this 1, -1 and 3. Let me write that 1, -1 and 3. Here next in the third row, I'll write the components of vector b, 2, -7 and 1. Now we need to find the determinant of this. Okay. So I, then this column, this row I have to delete and I have to focus only on this part, right? Let me change my pen. Okay, yeah, now I have to focus only on this. -1 into -1, -1 into -1, -1 into 1 is -1, 3 into -7 is -21. Okay, next -j, now I'll delete this column and this row. I'll get 1 into 1 minus 2 3s are 6. Next I have k. I'll delete this column and this row. I'll get 1 into -7. -1 into 2 is -2. It will become +2. Okay, so this is what I get. So I get I. This will become +21, which is +20. So this will become 5j, and this will become -5k. So I need to find the magnitude of this vector. That will give me the area of the parallelogram. Magnitude is nothing but the square root of the component, square of the components. 20 square plus 5 square minus 5 square. So yeah, so 20 square is 400, 5 square is 25. So you get a square root of 450. So this is the area of the parallelogram. So whenever area is asked, you just need to find the cross product and then find the magnitude of that vector. That will give us the area of the parallelogram. Moving on. Yeah, again this was asked in 2023. So this is the expected question. So we need to prove this. Okay, we need to prove the section formula. So we have vector A, and vector B, and there is another vector R which divides this line AB in the ratio m:n. So the most crucial part in the derivation is simple. AP by PB is equal to m by n. If you know this part, you can prove it very easily. Okay, let's see how. I'll cross multiply these two. I'll get NAP is equal to MPB, taking vectors on both the sides. Okay, now is the crucial part. Vector AP, look at the figure. AP is nothing but see, observe carefully, this is my AP. Vector AP, where is my head? This is my head, this is my tail. Head minus tail, head is OP, and my tail is A, right? So OA, simple. What is OP? OP is nothing but R and OA is A, right? Similarly, PB. The position vector of the head minus the tail. Head is OB minus OP. OB is nothing but B and OP is R. So I'll just substitute here back. AP, what we have got, R bar minus A, and PB is nothing but B minus R. Okay, on solving this you will get this. Okay, MB bar plus NA bar by M plus N. So I am not going to go into the calculation part, you can do it on your own. So the most important part is this. If you can do this, the other steps will come naturally. So just keep in mind, take these two vectors in the same direction, vector AP and PB. If you take in opposite direction, you will not get the answer. So make sure to take these in the same direction. Okay. Okay, moving on. This is the expected question. Okay. Again, a similar question we had solved. Find the unit vector in the direction of vector A is equal to 2i plus 3j plus k cap. So this is it is similar to the first question. All we have to do is first find the vector a and divide it with the modulus of the vector, magnitude of the vector. This is nothing but the magnitude, and this will give us the unit vector. So take this as a homework and tell me the answer in the comments. I'll check there, okay, as we have solved this question. Moving on, okay, define collinear vectors. Okay, this was asked in when was it asked? It was asked in 2022. Collinear vectors means vectors that are parallel and the angle between them is 0 or 180 degrees. These are called collinear vectors. Direction is not important, only they need to be parallel and they can be placed anywhere. They need not be like this. It is not a compulsory that their tail should be joined. They can be anywhere. The vectors can be anywhere. All these vectors are collinear vectors because they are parallel and the angle between them is 0. If I take both the vectors in the same direction, the angle will be 0, and if I take them in the opposite direction, the angle will be 180. If the angle is 0 degrees or 180 degrees, then we call them collinear vectors. Moving on, yeah. So we have got find the position vector of R which divides the joining 2 points PQ whose position vectors are so and so. Okay, we had just derived this. Okay, so let's take this P and let's take this Q, and this is our R. Let's call this vector A, this vector B, and this vector R. This is our origin. Okay, so vector A is I plus 2j minus k, and B is I minus I plus j plus k. The formula that we know is mb plus na by m plus n. Just we need to substitute. What is m by n? 2:1. So I'll just substitute 2 minus I plus j plus k. N is 1. A is I plus 2j minus k. 2 plus 1 is 3. Okay, so we just need to solve this. Minus 2i plus I minus I plus 2j plus 2j 4j plus 2k minus k plus k. So this is the vector which divides A and B in the ratio 2:1. So we have just substituted this formula. So how to substitute? See this. This I have taken as vector A and this I have taken as vector B, and 2:1. 2 will be multiplied with this, 1 will be multiplied with this. Okay, divided by 2 plus 1. So this question can be expected. A derivation can be asked or a question on the formula can be asked. So again a similar question. So here they are asking us find the area of the parallelogram whose adjacent sides are A and B. Take this also as the homework and you can tell me the answer. In the comments you can put question number 9 and the answer. Okay, we just need to find the magnitude of the vector. First find the cross product and then the magnitude of this vector. That will give you the answer. Okay, moving on. Okay, this one is an interesting question. 3 vectors A, B, C satisfy the condition A plus B plus C is equal to 0. Evaluate the quantity, this one. Okay, if magnitude of vector A is 1, magnitude of vector B is 4 and C is 2. So for this we need to know this identity, A plus B plus C whole square. You have studied this in your lower classes. This is nothing but A B square plus C square plus 2 A B B C plus C A. If you know this, you can solve this. So this, if you come to this part, LHS part, it is 0. They have already given us. And square of magnitude vector A, vector B, magnitude of square of the B vector, square of the C vector, and this quantity is nothing but your mu. Okay, yeah. So 1 plus 16 plus 4 plus 2 mu is equal to 0. So your mu is nothing but 15, 21 minus 21 by 2. This question can be solved if you know this. Okay, if you don't know this, you will be in trouble. So just remember this formula, and you will be good to go. Moving on, define a unit vector. Unit vector is a vector whose magnitude is 1. Okay. A vector which has magnitude 1 is straightforward question. Find the vector joining the points A and B. So you have got 2 points A and B. We need to find vector AB. Okay. So let us say take our origin O here. This is our OA and this is our OB. Okay. So if you observe vector AB, its head is, this is the head, and this is the tail. Head minus tail. Head minus tail. Head is B. Position vector of head is OB. Position vector of tail is OA. So first OB. OB is nothing but, so first let me write the points 2, 3, 0. This is -1, -2, -4. So your OB vector is nothing but the same thing you have to write. Just put the components, minus I cap, minus 2j cap, minus 4k cap, and you have OA, which is 2I cap plus 3j cap and 0k cap, and I'll just substitute them. Minus I minus 2j minus 4k minus of 2I plus 3j. So what do I get? Minus 3I minus 5j minus 4k. So this is what you get. This is your AB vector. So just remember position vector of B minus position vector of A. Okay, that is what that will give you. Head minus tail also you can take. Position vector of B minus position vector of A. Remember this. This can be also asked in your exam. Moving on. Okay. Yeah, define a negative vector. Okay. So a vector having the same magnitude as that of the given vector A and the direction is opposite to that of A is called negative vector. So it is as simple. So if the direction is different, so this is your vector A, so your minus A will be this one. If the direction is changed, then it will give us the negative of that vector. Okay. Yeah. Again a similar question. Find the projection of vector A on vector B. So the formula is A dot B divided by mod B. This is projection of vector A on B. A on B. And if they have asked projection of vector B on A, then the formula changes. Then it will be A dot B divided by mod B, mod A. Okay. Remember this. Okay. So look at the question what they are asking and accordingly use the appropriate formula. Okay. Yeah. Again there is an interesting question. Find a unit vector perpendicular to each of the vectors A plus B and A minus B. So we need to find a vector that is perpendicular to these two vectors. Okay. We know cross product gives us a vector that is perpendicular to both the vectors. So if I have two vectors, say C and D, their cross product will give me a vector which is perpendicular to them, right? So I just need to find the cross product of these two. So I need to find A plus B cross A minus B. Once I find this, I'll get some vector V. As they are asking us unit vector, we need to find the unit vector. Unit vector is nothing but the vector divided by its magnitude. So the first step is find the cross product, second step is find the unit vector, and you will get the answer. Okay. So you can solve this and tell me in the comment section. Okay. Yeah. So before we go to the next question, so I have prepared a PDF of all the questions. You can find the PDF in the description. You can download that and refer the answers with answers I have provided. Yeah, you can use that. So if the vectors are parallel, find the value of M. When two vectors are parallel, their components will be in proportion. Okay. So Here 2 and 4 will be in proportion, 3 and m will be in proportion, 6 and 12 will be in proportion. 2 by 4 is equal to 3 by minus m is equal to minus 6 by minus 12. So here I will get 1 by 2 minus 3 by m. Here again I will get 1 by 2. I can use any equation, so and cross multiply, I will get minus 6 equal to m. So simple question. So only remember, when two vectors are parallel, their components will be in proportion, 2 by 4, 3 by minus m, 6 minus 6 by minus 12. Okay, yeah, simple question. Yeah, this is a interesting one. So they have given us, if a plus b dot a minus b is equal to 8 and modulus of a is equal, magnitude of a is equal to 8 times of magnitude of b, then find ab. So this is a direct expression. Whenever this is even, this is nothing but magnitude of square of magnitude of a vector square of magnitude of b vector is equal to 8. They have already given us the value of a. A is 8b. So 8b square minus b square, and I think you will get the answer. This is nothing but 64 b square minus b square is equal to 8, which is nothing but 63 mod b square is equal to 8. So the magnitude of vector b is square root of 8 by 63. Okay, yeah, simple. So the only thing is you need to know this, a plus b, a minus b is equal to a square plus b square. Okay, find the value of x for which this is the unit vector. So they have given us the given vector is a unit vector. That means the magnitude is 1, right? Unit vector has a magnitude that is equal to 1. So mod v magnitude is 1. That means root of the components, square of the components is equal to root of 3x square, which is nothing but root 3x is equal to 1, x is equal to 1 by root 3. Yeah, moving on. If a is a unit vector, then find. So this one we have already seen. This is nothing but x square minus a square is equal to 8, and a is a unit vector. That means the magnitude is 1. So 1 square is equal to 8. So your x square is equal to 9, x is equal to 3. So this is what is the answer. Simple question. Moving on. Again, the vector AB is this and OB is this. Find the position vector of OA. Okay. So you have AB. Okay. OB. This is your OB and they are asking us OA. Okay. If I take vector AB is nothing but position vector of B minus position vector of A. Position vector of the head minus position vector of the tail. Position vector of B is nothing but OB minus OA. So I just need to substitute here and find my OA. Okay, AB is already given to us, 2y minus j plus k. OB is nothing but 3i minus 4j plus 4k, and OA, that is what I need to find. So this can be easily found. Just shift this all of them here and you will get your answer. I have attached a PDF. You can refer that and you will get all the solutions. Okay. Okay. So they have given us this expression. Prove that A and B are perpendicular. Okay. So here what we will be doing is we will be squaring on both the sides. Okay. That is the trick. Squaring on both the sides. That will give us a square plus b square plus 2ab. Here a square plus b square minus 2ab. So this will cancel and we will get 4ab is equal to 0. A dot b is equal to 0. If the dot product is 0, that means they are perpendicular. A is perpendicular to b because the dot product is 0. Okay, moving on. Okay, interesting question. Find the angle between the vectors. Okay, how do we find the angle? So we know the formula, cos theta is equal to a dot b divided by the magnitude. So using this we can find out. First we will be finding the dot product. I plus j minus k, I plus j plus k is equal to the magnitude. So the magnitude is fair, simple, 1 square plus 1 square plus 1 square, 1 square plus 1 square plus 1 square. The sign is not important because we are taking the square. Okay, 1 plus 1 minus 1 divided by root 3 into root 3, which gives us 1 by 3. So the theta is equal to cos inverse of 1 by 3. Okay, simple question. Moving on, find the sine of the angle between them. Okay, so sine is something which comes in the formula of cross product. So A cross B is equal to mod A mod B sine theta. Okay, from this formula sine theta is nothing but, if I take modulus on both the sides, if I take the magnitude on both the sides, what do I get? A cross, this n cap will go away because magnitude of n is 1, right? Now from this formula sine theta is equal to the magnitude of the cross product divided by the individual vectors. So this will give me the sine theta. So this is how you can find. Just substitute here and you will get the answer. Moving on, if two vectors A and B are such that this and A dot B is this, find A minus B. So in this type of questions, the simplest method is to square. Take the square of A plus A minus B whole square. What do you get? A square plus B square minus 2AB. All of them are given. A is given, that is 2, B is 3, and A dot B is also given to us. So this gives us 4 plus 9 minus 8, which is nothing but 5. So A minus B is equal to root 5. So you can keep this in mind. Squaring is very important in vectors. This manipulation is mostly used. Show that the vectors are collinear. Okay. So collinear is nothing but parallel. Okay, just look at the components. 2 by minus 4, minus 3 by 6, 4 by minus 8. So all of them are equal, as you can see, which is minus 1 by 2. Because all the corresponding components are in proportion, we can conclude that the vectors are collinear. Okay, this is one method of doing. You can use other method also, where you can prove your vector A as lambda B. You can do this also and find the value of lambda. That is another method. You can follow both the methods. Okay. Yeah, moving on. If A, B, C are such that A plus lambda B is perpendicular to C, then find the value of C. Okay. If two vectors are perpendicular, we know that their dot product will be 0. Okay. So we'll just use that. A plus lambda B dot product with C is equal to 0. First find A plus lambda B, okay, which is nothing but your vector A plus lambda times your vector B, and your C vector is as it is 3i plus j. Find the dot product and you will get the value of lambda. I think the lambda value here is yeah, find that and you can tell me in the comment section. Okay, you just need to find the dot product, or we'll do this question. Okay, let's do this. Okay, let me do this. This is your A plus lambda B and your vector C is 3i plus j. Okay, so this is nothing but 2 minus lambda, 2 plus lambda, and this is 3 plus lambda, and here you have 3i plus j, which is equal to 0. So 2 minus lambda into 3 plus 2 plus lambda into 1 is equal to 0, which gives us 2 3s are 6 minus 3 lambda plus 2 plus lambda equal to 0. So it gives us 8 minus 2 lambda is equal to 0, which is nothing but lambda is 4. Okay. Yeah. Yeah, that's all for today's session. I hope this was helpful session. The PDF, you can find the PDF in the what do you say, in the description. You can download the PDF and you can go through all the questions from 2023 till 2014. All the questions are present there. Yeah, if this session was helpful, you can like this video, and to get more such updates, I will be covering all the chapters. I will be trying to cover all the chapters, so you can subscribe to my channel so that you don't miss any of my videos. Thank you.